Today we're doing best buys. So best buy is to find the cheapest. All right, that's the one that's going to save us money. All right, so we need to compare prices, but we can't just compare prices when things come in different sized containers. All right, so we need to compare the same quantity and then we can compare the prices. So in Australia, we've actually got something called unit pricing. It was introduced not that long ago because people were trying to sit there with their phones and their calculators and try and work out what is actually the best buy here. So they introduced it, and if you have a look at any price, if you go into Coles or Woolies or somewhere like that, and have a look at the price, down in really small writing, at the bottom of the price tag on the shelf, it will tell you how much it is per 100 grams or per 100 milliliters, whatever they're comparing it with, and they'll compare all the different brands and all the different sizes in the same way, so you can just look for the cheapest one. So they've done a lot of the hard work for you. But in maths, we're going to have to do this work ourselves. So let's have a look at these questions. So in the first one, we're finding the better buy. Better means we're comparing two different things, not best, which would be comparing three or more. So we're comparing 6 notepads for $15.50 or 8 notepads for $20. So firstly, we're going to write down 6 notepads equals $15.50. Now we're going to find out what the price is for one notepad. So for me to go from 6 to get an answer of 1, I'm dividing by 6. And so I'm going to do exactly the same thing on the other side here and divide by 6. Now you're going to get some very small decimals sometimes. You do need to write the whole decimal out. We're not rounding anything at this stage. So we're going to write 15.50 divided by 6 in the calculator. And if we do that, press equals, that's what we get. So I'm going to write that decimal down, no rounding. So it's this one up here, get rid of that, 2.58, and there's lots of 3s. I'm just going to write that as 3 recurring at the moment. All right, so let's have another look at the next question now. We've got 8 notepads for $20. So for me to go from 8 to get an answer of 1, I'm dividing by 8. So I'm going to do the same to the other side. And let's do that on the calculator. So I'm doing 20 divided by 8, and I get 2.5. So now I'm going to compare these two decimals. So they're very close, but which one is the smallest decimal? Because that's the one that's going to be the cheapest. Well, it's 2.5, they look the same up to there. But when you get to here, this one starts to have zeros now. These are all zeros in these positions. So which one's the cheapest when we're looking at this decimal place here? The 0 is lower than the 8, so this one's the cheapest. Give it a tick. That's the one we want to be buying. So we're going to say, therefore, 8 notepads for $20 is the one we want to be buying. That's the better buy. All right, let's look at the next question. We have 45 grams of chips for $2.10. Let's write it down. 45 grams equals $2.10. I have to go to get an answer of 1, so that means I'm dividing by 45. And over here, I'm going to do the same thing. So you go to your calculator, just type in 2.10 divided by 45 and press equals. And that's what we end up with. So we're going to write that down, 0.04. Oh, written it down the wrong one again. Okay, so it's up here, 0.04, and then it was lots of 6s. Now, I don't want you getting confused with what that calculator's doing. So if you look at it, it does have a 7 on the end. Never look at the last digit on a calculator, it has been rounded off. So the 6s do repeat. All right, we're looking at the next one. To go from 150 to get an answer of 1, I'm dividing by 150. Do the same to the other side. Okay, so we're doing 6.50 divided by 150. And let's see what we get. There it is. Okay, so we're writing 0.04 and lots of 3s. 3 recurring. So see how close those decimals are? So we're getting 1 gram of chips and seeing what the price is, 1 gram of chips and seeing what the price is. Now which one's the lower decimal for the cheapest price? Well, it's the same. This is where it's different. Which one's smaller? Which one's lower? That one, so that's the cheapest. So this is the cheapest one, 150 grams for $6.50. That's the answer to our question, the cheapest chips. All right, number 2. We're looking at which size is the better value for money. Better value is the same as better buy. It doesn't matter what sort of wording they use. So we have a 2-litre bottle of Coke for $3.25. They're the big bottles. Or we have 6 cans of Coke, and the cans have 375 millilitres in them. Okay, so we're paying $3.85 for that. So this is a bit trickier because we have to get our quantities the same. So we're going to start with our 2-litre bottle of Coke, which costs $3.25. We're going to just get that to 1 litre. All right, we're always going to 1 when we're comparing things. So what do we do to 2 to get an answer of 1? We divide by 2. Do the same over here. And get your calculator and put that in. We're doing 3.25 divided by 2. And you get 1.625. Copy it down. Okay, next one. We've got 6 cans for 375 millilitres. Now if I multiply those, altogether I've got 2,250 millilitres of Coke in these cans. So I'm going to start my working with 2,250 millilitres equals $3.85. Now, I'm going to convert it to litres because this one we were working in litres. So if we convert millilitres to litres, we're just doing a conversion here. We're going to a bigger unit. So we divide, and milli is 1,000. So if you do 2,250 divided by 1,000, that will give you 2.25. Right, now we're starting our working for our unit pricing that we've been doing. So to go from 2.25 to get an answer of 1, we have to divide by 2.25. And we do the same to the other side, divide by 2.25. Let's see what our calculator says. So we're typing in 3.85 divided by 2.25 equals, that's what we get, 1.7 and lots of 1s. 1.7, lots of 1s, which means we have 1 recurring. All right, so let's look at our 1 litre cost up here and our 1 litre cost down here. Which one is cheaper? Well, they both start with 1 point, and this is where they become different. Which one's smaller? Here. Okay, so the 2 litre bottle is cheaper. So we write therefore, that's what the 3 dots are. The 2 litre bottle of Coke for $3.25, that's going to be your best buy or your best value for money here. All right, now the next one, we're comparing 3 different things, and there's a few different units being used with grams and kilograms, so we'll have a look and see what we can do here. All right, so again, best value for money. They use the word best because we're using 3 or more things here. All right, so let's look at the first one. We've got 450 grams, and that costs $3.99. Now remember, all the time we're going to find 1 in each of these workings. We're going to go to 1 gram. So how do I go from 450 to get to 1? I divide by 450 and do the same over to the other side. Okay, I'm going to work that out on the calculator. See what we get. So it's 3.99 divided by 450. And we get, whoa, That's what we get. So you've got to write that down, and I'll explain it to you in a minute. So just copy what your calculator says. Now remember I told you to ignore that last digit on the decimal, okay? So we're not looking at that 7 on the end. Okay, we'll deal with the rest of what that means in a minute. Okay, let's look at the next one. So we're doing 600 grams equals $5.15. And we're trying to find what 1 gram equals. So to get from 600 to get to 1, we're dividing by 600. Let's come to the other side and do the same thing. We've got to keep everything balanced in maths. If you do something to one side, you do it to the other. So I'm going to divide that by 600 and see what the calculator says this time. See if we get something just as strange. Have a look. Yes, we do. So I'm going to copy that down as well. And underline it. And now we're doing the next one. So this time we've got 1 kilogram. So 1 kilogram equals $8.95. So we're not going to go any further till we get the units the same as the other two. The other two were in grams. So we're going to make this in grams before we continue our working. So all we're doing here is converting 1 kilogram into grams. Okay, so it's going to be the same quantity, it's just written in a different unit. All right, so we're going to grams, which is smaller. So that means we're timesing by 1,000 because kilo is 1,000. And that gives you 1,000 grams. Okay, we're going to keep this. So all we haven't done anything really except just change the units of what we were doing. Right, now we're going to go and do what we normally do, which is find 1 gram. How do we go from 1,000 to get to 1? We divide by 1,000. And how do we, that means we have to do the same thing over here. Divide by 1,000. And I know the answer to this, but I'm not sure how the calculator is going to give it to me, so I'm going to type it in. Yep, it's giving it to me like that. Now, some of you may not be getting these answers. You might be actually getting a decimal. If you're getting a decimal, just write down what decimal you're getting. Okay, I'll explain that part to you in a minute. I'm just writing down what my calculator is saying. Now, this is something that gets done in year 9. We're only in year 8. So I'm just going to explain what we need just to get through this question. All right, so if you have a look, they all have this, don't they? So they all have times 10 to the power of minus 3. So I'm not really going to worry too much about that. I'm just going to ignore it and just look at these other numbers and see if we can find the smallest one. So we've got 8.86 recurring, 8.583, 8.95. They all start with 8 point. They go different here in the first decimal place. All right, so we have an 8 in that spot, 5 in that spot, 9. The smallest is this one, so that's the best value for money. So we've got our answer, and we didn't even need to worry about what those times 10 to the minus 3s mean. Okay, so that's going to be your cheapest washing powder. All right? Now, some of you, as I said, may not get that off your calculator. Some of you might have actually got this decimal. Okay, some of you might have got that. Some of you might have got this for this one. And some of you might have got this for this one. So if you did get those decimals, that's okay. They all start with 0.00, 0.00, 0.00, so we're not looking at that. And then they all have an 8. This is where they become different. And again, which one of those is smaller? 8, 5 or 9? It's the 5. So you're still going to get that answer. So it doesn't matter what sort of answers your calculator is giving you, you can still get to this answer. Okay, so we'll leave it there. Have a go at your homework, but make sure all of that working is shown.